Welcome all. Today we are just going to see about the learning methods in artificial intelligence. So learning methods are the techniques used by the artificial intelligence system to acquire the knowledge, improve the performance and making better decision based on experience, data and interaction with the environment. Just like a human, we can learn through the observation, practice and experience. Artificial intelligence systems use different learning methods to become more intelligent over time. So it is a process through which AI system gains knowledge and improves its performance by using a data, experience, examples, and the suggested feedback. Why do we need then learning methods in artificial intelligence? So AI can follow only the fixed rules, cannot improve the performance, cannot adapt to the new situation without the learning. But with learning, we can learn through from the experience. It is also used to improve the accuracy as well as efficiency, adapts to changes the environment, solves the more complex problems. So how a learning method works? So usually it will be receives the data, analyze the information, generating the knowledge, make the decision and improve the performance. So this is about the learning method. Let me see one by one. These are the different types of learning methods that we are just going to see. One is Bayesian learning, learning with hidden variables, EM algorithm, artificial neural network based learning back propagation, support vector machines, reinforcement learning, adaptive learning, multi-agent based learning, ensemble learning, learning for decision making, distributed learning, speed up learning. So speed up learning and generalized learning. So this is about the learning method. So now we'll see one by one about the thing. First we'll be seeing about the Bayesian learning. So Bayesian learning is a statistical learning method in artificial intelligence that uses the probability to make the predictions and decisions. It is especially based on Bayes' theorem, which is a mathematical function which used to help to update the probability of an hypothesis when new evidence becomes available. Instead of making an absolute decision, Bayesian learning works with the probability and it helps to continuous improvement of prediction as more data is received. So this machine learning approach that uses the Bayes theorem to update the belief or prediction based on the new evidence. So in mathematics, we have been solved with the concept name called probability and queuing theory or probability of statistics. So how the probability can be helped with the Bayes theorem. So it is used to calculate the probability of event based on prior knowledge and new evidence. So P of A divided by B equal to P of B divided by A into P of A divided by P of B. So here P of uh, A divided by B, the posterior probability, P of B divided by A, it will be of a likelihood, and P of A will be of prior probability, and P of B will be of probability of evidence. So simple explanation. Suppose a doctor wants to know whether the patient has a disease. The knowledge, prior knowledge will be of 1% of people have the disease. The evidence for it, the patient test result is positive. The learning of Bayesian, the probability of having the disease is updated using the test result. So the old belief plus new evidence equal to updated belief. So let's see how the Bayesian learning or Bayesian's theorem that can be work with the artificial intelligence. So initially it will be started with the prior probability. The system begins with the initial belief. Collect each and every incidence or evidence. So the new data is received. So apply the Bayes theorem. So the probability are updated. Then you can calculate the posterior probability. A new prediction is generated. Repeat with each and every new evidence. The model continues that can be improved. So the good example for Bayes learning. So we are just training a data with a spam probability. So will be of word called free win meeting, there will be of having a high and low. New email win a free prize analysis, the words are win, free and price are commonly found in spam email. So prediction will be spam probability plus that can be equal to high. So result will be email equal to spam. So according to the medical diagnosis, suppose one person is having the fever, the disease occurs with the 2% of population. So the patient has fever, cough, and fatigue. Bayesian analysis, the symptoms increase the probability of the disease. Result will be of disease probability equal to 85%. So the doctor can make the better diagnosis. So this is the other example for it. So now there are different types of Bayesian learning are there. One is of Navy base. Second one is Gaussian Navy base, multinomial Navy base, Bernoulli Navy base. So Navy base used for classification problem in the machine learning as well as the deep learning concepts. So example, spam detection. Gaussian Navy base used when data is continuous. So predicting the student's mark in the classroom. Multinomial Navy base used for text classification. So for example, we can reading a newspaper, that article categorization, which will be of really a multinomial Navy base is a good example for it. And Bernoulli's Navy base works with the binary features. Similarly, yes or no questions, take it as a survey. So that is a good example for it. The real-time characteristics that can be used with the Bayesian learning will be of based on probability and is the uncertainty effectively. Continuous updates knowledge works with incomplete information, fast and efficient, suitable for classification task. So the main advantages of Bayesian learning will be of it is simple and easy to implement for probability calculation, fast and training prediction that requires the less computational power, works well with the small data sets, and it can be handles the missing data, so with the incomplete information, supports the incremental learning and good for probability decision. So disadvantages of Bayesian learning, it will be of carry with independent assumption, accuracy may be lower, requires probability estimation, sensitive to the data quality, and it will be of represented with zero probability problem. Application of Bayesian learning: email spam detection, medical diagnosis, weather forecasting, sentimental analysis, and some other example will be there. So while summarizing the Bayesian learning, so it will be of powerful AI method that uses the probability theory to make the predictions and decision under uncertainty. By a new evidence, a Bayesian learning enables intelligent system to learn, adapt, and make accurate prediction in an application such as spam filtering, healthcare, fraud detection, weather forecasting, and recommendation systems. Next, we will be moving to learning with hidden variables, that is EM algorithm. The expansion of EM is said to be as an expectation maximization. So, expectation maximization algorithm is also a statistical learning method or technique used to estimate the unknown parameters when some variables are hidden or not directly observable. So, EM algorithm is an iterative learning method used to find the best model parameters when the data set contains hidden or missing variables. So, here what is an hidden variable? So, hidden variables is a latent variable or a variable that influence the data but cannot be observed directly. So, if the student mark will be there, example, so that will be of an hidden variable will be of intelligent level. So, disease diagnosis, actual disease condition. So, these are some examples. Why do we need EM algorithm? So, the actual disease causes the symptom like a fever or cough that may be unknown. The disease will be of hidden variable. The EM algorithm helps to estimate symptoms plus hidden disease equal to the predictions. So the basic idea and how the EM can be expanded in the view of E step expectation, M step expectation. E step expectation estimate the hidden variables using the current knowledge. M step maximization update the model parameters using the estimated hidden variables. These are the two steps that can be repeat for the model reach the best solution. So how the EM algorithm will be works? It is of initialize the parameters with the random parameter values, and each step that can be have to estimate the probability of hidden variables. Maximization step, that is of M step, that can be update the parameters to maximize likelihood. So check the convergence. So if the parameters stop changing significantly, then stop. So this will be the flow. So it will be generally starting initializing the parameters, expectation step will be there, and estimate the hidden variables. Maximization step will be there, M step will be updating the parameters, and it will be of converged. If it is of yes, final model will be there. No, it can be repeat the steps once again. So understanding the E step, the purpose estimate missing or hidden information. Suppose we have two groups of students, intelligent students, average students, but group labels are missing. Student A equal to 80 percentage of intelligence, student B will be of 20 percentage of intelligence. These are the probability estimates. Understanding the M step, update the model parameter using the estimated probabilities. After estimating the student groups, the average marks of intelligence group will be of 90, average marks of average group will be of 65. So this is the real time example of it. So other example, that is of disease diagnosis, we can take it as an observed data that will be of fever, cough and fatigue. Hidden variable that can be of actual disease. An EM estimate, patient A will be of having 75 percentage of flu, patient B will be having of 20 percentage of flu. So that will be the update of disease probability repeated. The characteristics of EM algorithm that can be represented with the works with incomplete data, uses the hidden variables. Iterative process will be there, it will be of repeated process once again. Probabilistic approach improves the model parameter gradually and finds the maximum likelihood estimates. Advantages of EM algorithm, it handles the missing data, that will be of example that can be of medical records with missing values, works with hidden variables, excellent for the latent variable problems. Flexible algorithm produces accurate parameter estimates, widely used in clustering, easy mathematical framework. Disadvantages of EM algorithm, make coverage to local optimal, sensitive to hidden initial value, computationally expensive, slow convergence, and requires the model assumptions. Applications will be medical diagnosis, customer segmentation, group customer into the hidden categories, image processing, speech recognition, NLP, bioinformatics. These are some of the implementation, that is of applications that can be used with the EM algorithm. So finally, the summarization of the EM algorithm. It is of powerful learning technique used when the data sets contain hidden or missing values. By repeatedly estimating the hidden information and updating the model parameter, EM gradually improves the model and discovers underlying patterns. Because of its ability, it can be worked with uncertainty and latent variables. It is widely used in clustering, healthcare, speech recognition, image processing, marketing, and many modern AI applications. So these are the summarization of EM variable. Next, we will be moving to artificial neural network based learning. In short form, it can be represented as an ANN. So it is one of the machine learning approach inspired by the structure and functioning of human brain. It consists of three different types of layers: input layer, hidden layer, as well as output layer. So it consists of interconnected processing unit called neurons, which work together to learn the patterns, relationship, and knowledge from the data. So ANN are capable of learning complex patterns that are widely used in modern AI applications such as image recognition, speech recognition, healthcare, and autonomous vehicles. So here in this learning method, in which a network of artificial neurons learn from data by adjusting connection weights to improve the prediction accuracy. So the human brain, how we are just going to process, input will be of eyes and ears that can be carried with the brain, and decision will be taken only from the brain. The input data in the artificial neural network, it will be passes through the artificial neurons, and prediction and output will be done over there. ANN mimics how the brain process information and learn from the experience. So as I told, there are three different types of layers available. One is input layer, hidden layer, and output layer. Input layer, which is used to receive the input data. Hidden layer processes the information and finds the pattern of it. Output layer produces the final result. So here there will be of having x1, x2, x3. Let take it as an example as an input. O will be having the neurons. O will be having the neurons and result will be of output. What is exactly a neuron? So neuron is a basic pre-processing or processing unit of neural network. Input will be done. Based on the input, it will be calculate the weighted sum. After that, activation function will be used, and finally, based on the activation function, you will be calculating the output of it. So really a big challenging for this artificial neural network. So nowadays they are using with the ANN concept. First of all, how the working model will be there. So calculating the input data, the training data will be provided. Then we'll be using a forward propagation. The data moves from the input layer to the output layer. Input plus hidden layer that can be tensed with output. Prediction is generated and it will be of leads to the positive results and calculate the error. So comparing with the prediction with the actual answer, they will be of some error occurs. Based on that error, we are just going to calculate with the back propagation technique. The network identifies which connection can be caused the error and finally updating the weights. Wrong prediction that can be adjusted with weights and it will be leads to the better prediction. And finally, it will be of training can be repeated once again. Whenever the error gets completed, it will be asked, the process can be asked according to the student. Okay, so this is the thing. And if you are just going to take it as in characteristics, so it has been inspired by the human brain. It will be learns from examples, handles more complex problems, and it is also used to improves with training, adapts to the new data, supports with pattern recognition. So advantages, it learns from the complex pattern. So with the identify the relationship difficult for the traditional methods. The example is face recognition, high prediction accuracy, and adaptive learning, and it has also handles the large data set. Fault tolerance, can continue with functioning even if the neuron fails. Automatic feature learning, these are the advantages. Moving to the disadvantages of ANN, so it requires the large training data, high computational cost, long training time, difficult to interpret, and risk of overfitting. The real-time applications of ANN that can be used in the real-time world, it is an image recognition which can be used to recognize the objects, faces, and handwritten characteristics. Speech recognition, Google Assistant and Siri nowadays we are using in um, Amazon as well as Google Chrome, Chat GPT, everything in WhatsApp also we will be recording and we'll be assisting the Google. Healthcare diagnosis and medical analysis, medical image analysis, banking and finance and recommendation system, weather forecasting for climate and rainfall prediction, everything that can be used with the ANN. So to summarize it, so it is one of the most powerful artificial intelligence learning method. So inspired by the human brain, it learns from data by adjusting the neuron connections and continuously improve the predictions. Because of its ability to recognize more complex pattern, and ANN is widely used in image recognition, speech processing, healthcare, finance, robotics, autonomous vehicles, and many more AI applications. Next, we will be moving to backpropagation algorithm. It's a good example for artificial neural network. So it is backpropagation of errors, most widely used in learning algorithm, and it is an effective algorithm used to train the ANN, which is especially in a feed-forward neural network, and it is of helps to neural network learning from mistakes by calculating the error in the output and adjusting the weights of the connections to reduce the error. Suppose if you are just going to calculate the 10 different types of images, so if you are just going to process over there with the 3 different types of layers, input layer, hidden layer, output layer. So suppose if it is of any error, if it is occurs, So there will be of classification as well as misclassification can be occur, and finally it will be rectified through the back propagation algorithm. So it is an supervised learning algorithm in which it is a neural network can reduce the minimization of prediction error by updating the weights in a backward direction from the output layer to input layer. Why do we need back propagation? So suppose if the predicted result equal to 90, the actual result will be of 100. Error, that 100 minus 90 equal to 10. So the network must learn how to reduce the error. So back propagation algorithm that is helps to determine which weight caused an error, how much each and weight can be adjusted. So let me take it as an human example. A student answer a question incorrectly. Teacher content corrects the answer. The student learns from the mistake and improves for the next time. So prediction that can be leads to the error and the correction can be done with the learning. So this is the basic principle of back propagation. How it is works? So there will be of two different types of phases. One is forward propagation and another one is backward propagation. Forward propagation, input moves forward through the network, the prediction is generated. Backward propagation, error moves backward, weights are updated. The process repeats until the error becomes very small. So how it is works? So first of all, it will be initialize the weight according to the random weights. So take it as zero point 0.5 and zero point 0.3 and will be of processing to the forward propagation. Pass inputs through the network. So let me take it as an input equal to 5. Then the output generated will be of 80. Predicted output. Calculate the error. Actual output will be of 100. The predicted output will be of 80. So the error will be of 100 minus 80 is 20. So that's why we are just going to calculate it with the forward propagation. Backward propagation, send the error backward throughout the network, determine which weight contributed most of the errors. Output layer, hidden layer, input layer. And finally, it will be of updating the weights. Adjust the weights to reduce the error, and old weight equal to 0.5 and new weight equal to 0.6. The network becomes slightly more accurate. So repeated again the forward pass to calculate the error, backward pass to update the weight, and repeat again and again. Error will be of minimum. So this is the how the training can be done with the back propagation algorithm. First of all, will be give the input data. Forward propagation can be done with the prediction, calculate the error. Back propagation can be applied and update the weights. Improved prediction will be stored in the repeat training. So this is a real time thing, and example for it, we can take it as a student result prediction. Input we can take it as an attendance and study hours. Actual result will be pass, network prediction will be fail, error exist. Back propagation adjust its weights. After training, prediction equal to pass, the network learns the correct path of it. So the characteristics of back propagation, it is an supervised learning method, uses forward and a backward process, adjust the weight automatically, minimize the prediction error, and learns the examples. So the advantages of back propagation: high accuracy, automatic learning, handles the complex problem with non-linear data, and supports the deep learning, adaptable that can be learned with the new data, and efficient optimization. Disadvantages of back propagation: it requires the large training data. Training with can be slow, high computational cost with the risk of overfitting, local minima problem, difficult to interpret. Applications will be image recognition, speech recognition, healthcare, everything that can be used with it in the real case environment. So to summarize the back propagation, so it is a core learning algorithm. It enables the networks to learn mistakes from propagating error backward and updating the connection weight. The continuous error correction process allows the neural network to achieve the high accuracy and makes propagation the foundation of modern deep learning system used in image processing, image recognition, speech processing, healthcare, robotics, finance, and other many AI technologies, and many other AI applications. Next, we'll be moving to support vector mission. In shortly, it be represented as an SVM. So it is a powerful supervised machine learning algorithm used for classification and regression. It is works with by finding the best boundary, that in here in mathematical term it can be represented as an hyperplane that separates the different classes of data. The maximum possible margin can be occur. So it be widely used with pattern recognition, image classification, text categorization, and medical diagnosis because of its high accuracy. So since it is to find the optimal hyperplane to separate the data points of different classes with the maximum margin. So initially the basic idea will be of two groups of objects are there, red balls and blue balls is there. The goal is to draw the line that separates the two group. Example, red balls will be there, blue balls will be there. Separating line is called as a decision boundary. SVM chooses the best possible boundary that keeps the maximum distance from the both the groups. So the terms will be of hyperplane, margin, and goal. The support vector will be of working principle will be of receiving the training data, plot the data points, find the possible boundaries line by line, select the optimal hyperplane with a maximum or minimum distance, and it can be calculated with the best hyperplane, classify the new data, and finally it will be predict whether the particular line will be of yes or no. And training the data will be there, and find the support vector, construct the hyperplane, maximize the margin, build the model, and predict the data whether the data is true or not. So this is about the support vector mission. So the characteristics, it is a supervised learning algorithm, find an optimal hyperplane, uses the support vectors, maximize the margin, effective for the high dimensional data, works for linear and non-linear problem. So the advantages will be it is mainly produces high accuracy classification, effective in high dimension whenever the many features exist, memory efficient, handles non-linear data, less overfitting, and good generalization. Disadvantages of SVM: slow for large data sets, difficult for parameter selection, high computational cost, less interpretable, sensitive to the noise. Applications of SVM: image classification, face recognition, email spam detection, sentiment analysis are the good examples of SVM. And finally, to summarize it, so it is a powerful supervised learning algorithm. By finding the optimal hyperplane with the maximum margin, SVM achieves the high accurate classification and prediction. So it handles both linear and non-linear data, makes it valuable for image processing, healthcare, finance, cyber security, text mining, and other AI applications. Next is reinforcement learning. So reinforcement learning is also a machine learning technique in which an agent learns by interacting with its environment. The agent performs action, receives rewards or penalties, and gradually learns the best strategy to achieve the goal. It is similar to human and animals learn through trial and error method. So it is an agent learns optimal behavior by taking the action in an environment and receiving the rewards or punishment as an feedback. So real time example, teaching a dog: when a dog performs the correct action, sit, the reward will be of treat. The dog learns faster. When the dog performs wrong action, no reward, avoid the action. So the AI agent learns the maximizing rewards. So there are different types of components are there available in the blocks in the reinforcement learning. Agent will be there. The learner or take decision maker will be of agent. Example will be of self-driving car. Environment will be of the word in which the agent operates. Example will be of chessboard for a chess A. State will be of current situation of an environment. So the position while we are just going to operate with the robo arm. Action will be of a move performed by the agent, and which will be of turning left, turning right, and moving forward and moving backward will be there, and reward will be there. So feedback received after an action. So especially this is a policy that can be strategy that can tells the each and every agent what action to be taken. So if it's obstacle ahead, it has been represented as a turn right. So how it is works with the reinforcement learning, it observes the environment, an agent identifies the current state, choose the action, performs an agent, reward the receive from the reward based on the environment given by the feedback, learn from the feedback and repeat it. The process continues until the agent learns the best action according to it. So now the good example for reinforcement learning is a maze solving robo. So goal will be of reaching the exit of a maze. So action will be of move up, down, move left, move right. Reward will be of reach exit equal to plus 100, wrong path equal to minus 10, and hit wall equal to minus 20. Learning initially random movements. After many attempts, shortest path found. The robo learns the optimal route. It is a good example for the reinforcement learning. So there are different types of reinforcement learning are there. One is of positive reinforcement learning and another will be of negative reinforcement learning. Positive reinforcement learning, it isn't rewards that can be given for the correct action. So reach the goal will be of 50 points. Behavior is encouraged. Negative reinforcement, it is often penalty or used to encourage or discourage, sorry, to discourage wrong actions. That is of collision equal to minus 50. Behavior is avoided. So the characteristics that can be lead with reinforcement learning, it will be learns with the trial and error method, uses rewards and penalties, no direct supervision can be required, improves over time and learns with optimal strategies. Advantages: learns from the experience for the labeling training data, handles the complex problems, adapts to the dynamic environment, discovers to the optimal solutions, continuous improvement, suitable for the real time decision. Disadvantages or reinforcement learning, it requires large training time, computational expensive, exploration can be risky, reward design is difficult and not suitable for every problem. So that is about the reinforcement learning. So to summarize the reinforcement learning, it is one of the powerful AI learning methods. It enables the agents to learn optimal behavior through the trial and error by interacting with an environment and receiving awards of or penalties. So because of its the ability to take intelligent agent sequence decision, reinforcement learning is widely used in robotics, autonomous vehicles, game playing systems, healthcare, finance, industrial automation, and many other AI applications. Let's we move to the next type of learning. It is an adaptive learning. Adaptive learning is also a learning approach, so in which an AI system continuously adjusts behavior knowledge or learning process based on the new data, experiences, as well as the environment changes. So here the traditional learning method, apart from it, the adaptive learning system does not remain fixed. They can be able to learn, adopt and improve automatically, and new information becomes available. So the basic idea, it will be of traditional learning, we have been saw in the previous video. So that is of train once, use a model and no further learning will be approached over here. In adaptive learning, it will be learns, receives the new data, update the knowledge, improve the performance and repeat continuously. The system keeps on learning and adopting. So the real time examples now we can be evolved with the adaptive learning is that, so learning and ride a bicycle. Initially it will be a fail down. The rider learns from mistakes. After practice, a balance improves. Eventually it will be of the person or a boy or a girl that will be ride successfully. This is the continuous improvement in an adaptive learning. So initially it will be works with the collection of data. The system receives the input from the environment, analyze the current performance, check whether the predictions or decisions are accurate, identify the changes, whether it will be of detect new pattern or changes in the data, update the model, improve the decision and repeat the model as the adopting and new information arrives. So the good example for adaptive learning is that the online learning platform. Initial situation, a student performs poorly in mathematics. Adaptive learning system, the system detects weak areas, algebra, geometric, differentiation, integration, everything that is of calculating with probability. So the action will be provided easier questions, additional practice and personalized lessons. Result will be student performance improves. So this is about the one example of it. So apart from it, there are different types of adaptive learnings are there. One is of supervised adaptive learning, unsupervised adaptive learning, and reinforcement adaptive learning, and online learning. So supervised adaptive learning, so use of labeling data and updates the model continuously. Example will be of student performance prediction. Unsupervised adaptive learning, it learns the patterns without the label. Example will be of customer segmentation. Third is reinforcement adaptive learning, it learns user rewards and penalties. Example will be of robo navigation. Online learning updates the model whenever the new data arrives. Stock market prediction. So the characteristics that can be involved with continuous learning: self improvement is needed, and response to environment changes, personalized decision making, dynamic knowledge updating, and it also reduces the performance degradation. So based on the process, it will be of moves through the experience feedback, performance evaluation can be done, knowledge can be updated with the improved performance. Advantages of adaptive learning, it will be of continuous improvement and its changing environment, personalized learning to improve the better accuracy, reduces the human interventions, learn the new patterns. Disadvantages of adaptive learning: computationally expensive, complex implementation, requires continuous data, and risk can be avoided with the incorrect adoption. Applications: real-time applications will be of e-learning systems, recommendation system, self-driving cars, healthcare, robotics. These are the some important applications that can be used with the adaptive learning. So apart from that, to summarize it, so it is an AI learning approach that continuously improve the performance by learning from the new data and changing the environment. It is also ability to adopt the personalized experience, update the knowledge dynamically, makes it highly valuable in education, healthcare, recommendation system, robotics, autonomous vehicles, cyber security, and many model applications. So this is about the adaptive learning. So next is multi-agent learning. So multi-agent learning, which can be represented shortly as an MAL. It is also one of the learning approach in which multiple intelligent agents that they can be interact, cooperate, compete, and learn together within the shared environment to achieve the individual or a common goals. Unlike a single agent system where one agent learn independently, multi-agent involves several agents that influence each other by learning the and decision making process. So multiple agent learn through interaction with each other, and environment can be improve the performance, achieve the goals of it. So system containing multiple agents, that is of robo 1 will be of collecting the items, robo 2 will be of transport items, robo 3 will be of store items. AI generates to work to complete the task at the particular time. Single learning agent will be of one agent can be involved with the environment for learning. Multi-agent, agent A, agent B, and agent C all together that can be involved with the environment for the learning. So based on the each and every system that can be of learning from own experience, other agent action, and environment feedback. So components of multi-agent learning will be of agent will be there, environment will be there, action will be there, rewards, communication will be there. So to tell about each and every components, agent will be of the learners in the system. So environment will be of the shared world where the agent operate. Action will be of operations can be performed by the agents. Rewards will be of feedback received after the action. Communication, each and every agent that can be share and exchange the information to it. So how the multi-agent learning works with it: observe the environment, choose the action, interact with the environment, receive the rewards, learn and update the strategies, repeat it. So the types is cooperative learning, competitive learning, mixed learning. These are the types of multi-agent system. So cooperative learning, the agent work together with a common goal. So competitive learning, agent compete against each other. Mixed learning, combination of cooperation and competition. So the real-time example that we can follow with the multi-agent learning will be of problem will be of move packages efficiently. There will be of three types of agent like robo A, B, C. Learning will be of each robo learns from best routes, obstacle avoidance, task allocation, results that can be represented with the faster package delivery. So there is an need, and need will be of and need and characteristics. So multiple intelligent agents share the environment, cooperation or competition, continuous interaction want to be there, and distributed decision making that can be involved with dynamic learning process. Advantages of multi-agent learning: it will be of faster problem solving, scalability, robustness, efficient resource utilization, suitable for complex environment. So disadvantages of a multi-agent learning will be of communication overhead, high computational cost, coordination complexity, learning instability, and security risk. Applications will be of robotics, autonomous vehicles, smart traffic system, game playing, smart grids, drone swarms, and supply chain management and telecommunication for the network traffic management. So to summarize it, we'll be having of AI approach, so in which multiple intelligent agents learn, cooperate, compete, and adapt with the shared environment by combining the knowledge and action. Each and every agent that can be enables with efficient problem solving in complex real world applications such as robotics, autonomous vehicles, traffic control, drone coordination, smart grids, logistic, and large scale environment of autonomous system. Next is ensemble learning. So ensemble learning in an artificial intelligence. So it is an multiple learning models are combined into make a prediction with a single model. There will be of three learning approaches there. Based on the three learning approach that can be combined and it can be represented with the single model. So the basic idea: many weaker learners working together can create a strong learner. Instead of depending one model, ensemble learning combines the output of several models to improve the accuracy, reliability, and robustness. So ensemble learning is a machine learning approach that combines the multiple classifiers or predictors to produce the more accurate and reliable predictions that an individual model works. When and why should we are using of ensemble learning? So the combined prediction is usually more reliable than relied with the any one student. Similarly, ensemble learning combines multiple models to provide and obtain the better results. A single model will be of training data, one model and prediction. Ensemble learning training model, there will be of multiple models are there, combining the results of it, and it will be predicts the final better prediction of the results. How it is works? So collect the training data, train the multiple models based on the example of decision tree, support vector machine, and neural networks. Each and every model learns from the input data. So generate the predictions, combine the predictions by voting or averaging, and finally you want to be predict with the final results. So that is a good example of ensemble learning. So in the diagram it will be of represented with it. So here the two different types of ensemble learnings are there. One is three different types of ensemble learning. One is bagging, boosting, and another one is stacking. So bagging is a train multiple models independently used with the different subsets of data. So random forest is a good example. Boosting will be of model that can be trained sequentially. Each and every model focus on correcting the mistakes of previous models. Example will be of AdaBoost, gradient boosting, and XG boosting. Stacking, the combine the different models used with the another model called meta learner. The meta learner how to best to combine the predictions. So the good examples will be of student result prediction. The decision tree will be there, SVM neural network models. So predictions will be decision tree, SVM will be of pass, neural network will be of fail. So pass will be of 2 votes and fail will be of 1 vote. So final output will be of pass. So the advantages of ensemble learning, it will be of use with high accuracies to perform the better than single model, reduce the overfitting, especially with random forest, reduce the robust predictions, better generalization, handle complex problems, and improves the stability. So moving to the disadvantages of ensemble learning: high computational cost, longer training time, complex implementation, reduced interpretability, larger memory requirement that requires storage for the multiple models. Applications of ensemble learning: medical diagnosis, fraud detection, credit risk assessment, weather forecasting, image processing, and spam detections are the good examples of ensemble learning. So to summarize this, so ensemble learning is a most effective machine learning technique because of combines the strengths of multiple models to produce the better predictions. By reducing the errors and improving the accuracy, ensemble learning is widely used in healthcare, finance, cybersecurity, image processing, image recognition, recommendation system, that they can be making the better decision making in a essential way. Next, we'll be moving with the learning for decision making. Learning for decision making is a process in which artificial intelligence systems learns from the data, experience, and feedback to make the best possible decision in a different situation. The goal is not just to learn patterns, but it is also used to select the most appropriate action that leads to desired outcome. So it is a system that acquires the knowledge from the data and experience to choose the optimal actions and make the intelligent decision. Why decision making important? Each and every intelligent system must decide what action to take, when to take, which option is best. Example, a self-driving car must decide, so stop, slow down, turn left, turn right, move forward. The quality of this decision determines the success of the system. So the basic idea will be of, first of all, we will be giving with the input, followed by learning from the data, knowledge can be acquired, and finally decision can be made with the more experience. So the component of decision making will be of environment, the situation in which the decision can be made. Example, in the road environment, business environment, and hospital environment. State, current state or current condition of the environment. So example will be of traffic light equal to red. So action, possible choices available. Example will be of stop, go and turn. Reward or outcome, result of action, self driving will be of positive reward, accident will be of a negative reward. Learning mechanisms from the past decision as well as outcomes. So how it is works: collect the information, gather the data from the environment, analyze the situation, generate the alternatives, evaluate the alternatives, select the best action, learn from the results, improve the future decisions of it. So it is a main important theme. So now we'll be seeing about the how specific approach can be not suitable, and the best scenario for representing the decision making will be of characteristics: goal oriented, learns from the experience, uses the feedback, handles uncertainty, and improves over the time. So the advantages will be of better decision for data and experience, continuous improvement, handles the complex problem, adapts to changing the condition, reduces human effort, and faster responses. Disadvantages of learning for decision making will be of requires large amount of data, computational cost, risk of incorrect decision, difficult to interpret, dependence on data quality. Applications will be healthcare, for diagnosis of disease, banking and finance, e-commerce, cyber security, manufacturing, and stock market applications. And to summarize it, so it will be of an AI systems to make an intelligent choices by learning from the data, experience, as well as the suggested feedback. By continuously improving their decision making ability, these systems can solve more complex real world problem in healthcare, finance, transportation, robotics, manufacturing, and other domains. So it is a key component of a model intelligence system because effective decisions lead to the better outcomes and improved performance. Next type of a learning is distributed learning. So it is plays a key approach in a machine learning in which the learning process is divided into across the multiple computers, processor, or devices that can be worked together to train the model. Instead of a single computer, the workload is distributed among many machines, making a training faster and more efficient. So here is a learning technique where the multiple computer systems collaboratively train the machine learning model by sharing the data, computations, or modeling parameter. Why do we need the distributed learning? So in the modern application generates a huge amount of data. So a single computer may take several days or a weeks or a month to process such kind of large data set. Distributed learning solve the problem by sharing the work among the multiple systems. Example will be of social media, healthcare records, online shopping transaction, and video and image data sets. So the basic idea of distributed learning will be of data sets will be taken. There will be of computers, n number of computers will be there, and combining the results, and final model will be multiple computers will be worked together. How the distributed computing works? First of all, it will be splitting the data. The large data set, it will be divided into smaller parts. So train the model in parallel. Each and every machine learning that can be assigned the data, it will be learns each and every model parallelly. Share the learning results. Machine exchange learned parameters. Combine the updates. A central server or coordination mechanism combines the update. Update the global model. A common model is created. Repeat the process continues until the model becomes accurate of it. So let me take a real-time example of it. So image recognition. So if you're just going to train the multiple number of many thousands of images for training the model. Traditional approach, one computer trains the model. Training time, it takes 10 days. Distributed learning, 10 computers share the work. Training time, it takes 1 day. Result, the faster learning with the same accuracy. So different types of distributed learning: data parallelism, model parallelism, federated learning. There are three different types of distributed learning are there. Data parallelism, the data set is divided among the multiple machines. Example, the data set can be divided into machine A, machine B, machine C. Each machine trains the model with the same as well as different data. Model parallelism, different parts of a model are trained on different missions. Example will be of layer 1 will be of mission A, layer 2 will be of mission B, layer 3 will be of mission C. Useful for very large neural networks. Next is federated learning. So data remains on local devices. Only model updates will be shared. Smartphones improves the keyboard prediction model. So how the model will be worked, and based on the characteristics uses the multiple computers for processing. Parallel processing can be done. Faster training, handles the large data sets, supports the scalability, efficient resource utilization. Advantages of distributed learning will be of faster training with the multiple machines work simultaneously. Scalability can be increased. Efficient resource utilization with support big data tools for the very data large data sets. Fault tolerance can be occurred with the entire system. Improved privacy. Disadvantages will be of complex implementation. Communication overhead will be happen with the exchange of information frequently. Synchronization problems, higher infrastructure cost, security risk. Application nowadays, the big data analytics, BDA, processing massive data sets, image recognition, NLP, healthcare, and autonomous vehicles, cloud computing, Google Cloud with Microsoft Azure for AI training in distributed cloud environment, scientific research for data analysis. So to summarize the distributed learning, so it is enables the multiple computers to work together in the training machine learning model by distributing the data and computational across several systems. It significantly reduces training time, supports large data sets, improves the scalability, and enables the model AI applications like set recommendation system, healthcare analytics, autonomous vehicles, cloud AI, and federated learning. Next, we will be moving to speed up learning. Speed up learning is learning technique in an artificial intelligence that aims to improve the problem solving efficiently by using previous experiences and acquired knowledge. Instead of solving every problem from scratch, the system learns shortcuts, rules, or strategies that help similar problems faster in future. So it is mainly used to improve the performance of problem solving system by reducing the time and effort required to solve future problem through experiences. So the basic idea, it will be of when a person solves a mathematical problem repeatedly, they remember the method and solve similar problems faster in next time. Solve a problem, store an experience, learn the useful knowledge, solve the similar problem faster. The main goal is to increase the speed and efficiency. Why do we need the speed up learning? Faster decision making, reduce the computational, and improve the efficiency. Whenever the new problem is given without learning, it takes long time. Whenever the new problem with the speed up learning it is given, So use of previous experience and making as a quick experience of it. How the speed up learning will be working based on the solve a problem. The system requests with the existing method, analyze the solution, store the knowledge, save an important information for the future use, encounter the similar problem, apply the learning knowledge, solve faster. So the good example is mathematical problem solving. First time we are solving with 25 into 25. Use of detailed multiplication problem. Learning store multiplication pattern. Next time 35 into 35. Use of learning shortcut techniques. Result will be of faster calculation methods that can be solved with it. And to move up with the characteristics of speed up learning, experience based learning improves the efficiency, and it is also used to reduce the search time, reuses the previous solution, enhances the problem solving performance, focuses on speeder rather than the knowledge discovery. And especially it is used for problem solving, improved efficiency, reduced search space, better over time, and it will be of having a diagrammatic representation how the speed up will be done. Problem will be there, problem solving module and goal state, which can be derived knowledge parameter with the pattern, and speed up learner will be of with the experience, and it can be improve the accuracy as well as efficiency used in the real time systems. And moving to the disadvantages of speed up learning, memory requirement is needed, and knowledge maintenance, limited generalization, initial learning cost, risk of incorrect solutions. And applications of speed up learning, game playing system, expert system, medical and legal decision support, navigation system, and financial system, making of fraud detection and transaction images. And GPS navigation application is also one of the important technique that can be used with the speed up learning. So to move to the final summary of speed up learning, it is an AI learning approach that focuses on improving the speed and efficiency of a problem solving by reusing previous experiences and learned knowledge. Rather than discovering entirely new information, it helps systems to solve similar problems more quickly, making it valuable in robotics, navigation, game playing, expert systems, autonomous vehicles, and other real-time AI application where faster decision making is essential. This is about the summary of learning methods. There are 11 categories are there, from the starting from the Bayesian, reinforcement, everything, and ending with the speed up learning. This is the conclusion of it. Thank you.